Hey guys, welcome to my video on determining whether something is a function or not. So today we're going to go through the different formats it could be represented to you in and how to decipher whether it is a function or is not a function. So to do this, we first need to recap what it means to be a function. So a function is a set of numbers where every input there is exactly one output. Okay, so every x value you plug in can only give one y value as its solution. If we plug a number in and get two answers, that's where we have a problem. So for instance, think of it this way. We drop a number into our function machine, right? The function machine does its calculations, and it should only have one answer, okay? So that's how we want to think about this. There should be no multiples answers coming out of our function machine. So what happens if you're given a set of points? All right, well, if every input has to have exactly one output, that means my input value cannot repeat. Okay, input value cannot repeat, because that means it has two answers it's being sent to. Now, for the most part, this is going to be my x value. So if we are given a set of points, right, and we look at the x value, all of the x values, and one of them repeats, we will not have a function. All right, so let's take a look. We have 1, -2, -1, and 1. Does my x value repeat? And the answer is yes. This is repeated twice. So this is not a function because 1 is sent to two different outputs. -2 and 3. Okay, so if your x value repeats, it is not a function. So now let's take a look at the second one. 1, 2, 3, 4, 5. Do any of those x values repeat? The answer is no. All right, so this is a function. Okay, now one thing you need to remember, it does not matter if the y value repeats. Okay, the y value can repeat as many times as it wants to, as long as the x value does not repeat. Okay, so that one is considered a function. So what about on a table? Well, if we're looking at tables are just sets of x's and y's, or inputs and outputs, okay? Typically, the first column is your input, so in this case is x. The second column is your output, so that's usually your y or your f of x if we're in function notation. So again, we are looking for repetition in this column. If any of the values in this column repeat, it is not a function. So if we take a look, this one is not a function. And again, similar explanation, because the input of 2 gets sent to two different outputs. Whereas if we look at this one, right, look at our input column, 1, 2, 3, 4. None of those numbers repeat, so this is a function. Okay, so determining from a set of ordered pairs and determining from the table are very similar. Now, every once in a while, they'll show you something with a mapping notation. So a mapping notation basically has all of the inputs in one bubble and all of the outputs in another bubble. And the arrows demonstrate which input gets sent to which output. So for instance, in this example, 1 has an arrow pointing to A. So that means if we were talking about an ordered pair, we'd be talking about the ordered pair 1, A. So how do we know if we have a function? Well, every input has to have exactly one arrow, because each arrow represents a relationship. So if we ever get an input that has two different outputs, in this case, 2 gets sent to both A and B, this would be not a function because we see that repetition. So in this second set of bubbles below, what is an example of what could be a function? Well, I could send each one of these directly across. That would be considered a function, right? Only one arrow from each. I could also, take this and send this to a repeat, right? Again, all we're looking at is if there is only one arrowhead coming from this. What else could I do? Well, I could take this and I could actually cross all the way over to the A, and that would be fine too. Now, I could do that with any of them, but as long as there is exactly one arrow coming from each, we have function. Okay? So now the last representation that we have to take a look at is graphing. How do we determine if something is a function when looking at the graph? Well, what we need to use is something called the vertical line test. And basically it says if you can draw a line anywhere on the graph and it hits a vertical line anywhere on the graph and it hits only one point, you have a function. So if at any point we can draw any vertical line and hit our graph twice, it will no longer be a function. Now, it could happen as many times as we want, okay? But as long as it happens once, it's immediately not a function. So what we do for this is we take our pencil, right? And we drag it along the paper, okay? And we say, since this is representing our vertical line, do we hit the graph at any point 2 times? And the answer is yes. Pretty much everywhere on this graph, if we draw the vertical line, we will hit more than 1 point. So this is not a function. Whereas when we do the vertical line test over here, right, no matter what vertical line I draw, I will always hit only 1 point on my graph. All right, so this would be considered a function. Okay, so one thing I want you to keep into consideration, if at any point we have a graph that looks like this, right? Basically like a piecewise function. If one of the circles is open and one is closed, that would be considered a function, right? Because there is exactly one value for every x value. But if at any point we have 2 closed circles, that is a big no-no, okay? That would be not a function.